what are large language models? It is typed 3 times by Bert, not me. So what is LLM? So large language models, as we've been talking here, have the outcome is text generation, classification, knowledge answering, translation, and dialogue flow. If you see the greenish layer, these are some of the large language model like LMD, Bloomberg has come up with a dialogue bot, a Blender bot, OpenAI, which we use it. And further, how to get into those by prompt engineering. Hugging Faces is the open source community. You can literally use the APIs or services to call these models, and some data-centric tooling. In terms of medical, I'll show you an example how that is done. So this is a landscape of how large language models, what they are used for, what are the meta and NLLB kind of use case, Blender bot. So what are the applications around this and how you can prompt into it. Now this is very interesting. Large language models are trained on features. Features is parameters, basically how much it takes in account to be trained on. So for example, 2018 Lemo, 94 million, BERT is trained on 350 million parameters, and Metatone by 2023 is 530 billion. ChatGPT was trained at 175 billion parameters. So this is the features which has been considered to train those models. Someone does not know what is a feature. Feature is the parameters you take to predict certain things. So in this case, ChatGPT has trained on the whole internet. So it has 175 billion parameters. So you can imagine the power of, I do not know how much parameters human brain takes, but you can imagine the power of prediction and accuracy. Now this is another example. If we increase the parameter set, how the output for certain task is changed. In this case, first output is at 350 million parameters. So you can see how it looks like. Next one is at 750 million, 3 billion, and 20 billion parameters. You can see how this particular image is shaped based on the input parameters it got. So that was introduction to large language models, and we'll go a little bit. It's a subset of deep learning, and it helps. We use generative AI out of it. So they are pre-trained models and fine-tuned for specific tasks. So these are not like you are training the machine learning model in like before you have to train the model and then put some prediction. This whole corpus is already trained, and you can prompt to get certain answer. You can also fine-tune and tune these models, do a transfer learning, do weight. You can also take different weight out of it and transfer weights. Those kind of things are done here. Look at this. So major applications around this is text classification, question answering, dialogue and summarization, and text generation, which we talked multiple times. The applications is used everywhere. Entertainment, finance, retail is unlimited in my perspective. So large language models are defined as the large data set with huge parameters. We looked at it, and the purpose is to create from an input a human-generated language kind of an output, and pre-trained models can also be fine-tuned. Benefits of having large language models is you can, like ChatGPT or OpenAI LLM models, in one model you can get multiple things out of it as long as you know how to prompt, or in terms of word embedding, in technical word, what are the word vectors you can throw into it and how you get maximum out of it. Fine-tuning process, we'll talk more detail in coming slides. How do you fine-tune after you get the output and retrain feedback to the large language models? These are some most popular as of 2023. This is the latest list. OpenAI ChatGPT, Google Palm, multilingual capability aiming to generalize AI system, DeepMind, academia research, Meta is focused on ethics. I was happy to know doing this. Baidu, which is based in China, they are understanding of different languages. I haven't gone deep into it. And now the last thing is a model like M2M, translate medical information. So medical is healthcare is a big initiative in large language models, and we'll see a use case around it. But you can make very specialized models even you have a large corpus to drill down to. For example, you just want to focus on a diabetes disease or cancer or COVID flu, you can fine-tune and get into those kind of situations. Medical LLM, so ChatGPT-4 has extensive medical literature, mostly research-oriented. You can also ask for open source data and research papers. It does point to you. I've done that myself. BioBert, there's another one which is fine-tuned biomedical text excellence. And then DeepMind, as I was saying, has pivotal protein structure of prediction. Genomics, PubMed, which is a medical research data for pharmaceuticals. I think Google has it. And then IBM Watson as a healthcare patient care, more on the corporate side. If you are from this industry, explore this. These are amazing things to know. Now, we looked at what are large language models, what are the most popular one, what is the purpose. Now, we'll see from a super user point of view, how do you use this large language model? So there's two concepts called prompt design and prompt engineering. Prompt involves instruction, context passed to large models, and prompt engineering is a practice of developing, optimizing the prompt to effectively use the language model. I was just browsing around, and prompt engineering is offering like 6-figure salary just to be a prompt engineer. So you can understand the demand and the efficiency required to do this kind of things. There are 3 ways you do prompting: generic language, which is predict the next word based on the simple typing the text. Instructional tuning, train a predict response, what you want, and ChatGPT has those kind of like student-teacher mindset, or you decide a persona, what you want to call yourself, and feed your persona to it and say, I need response in this way, and it will give you. And the last one is dialogue, which is instructional style content generation. So word prediction, inside ChatGPT or inside large language model, this is what is happening. A vector representation of an input is generated, and tokens are passed to the large language model. And based on word to vector, if you have seen, or word text to vector, those kind of, if you have seen those algorithms, that's what it's doing internally. So it will take the most likely word which has more weight. Based on that, it will generate the next text. There's no, these are number driven, like prediction of what should be the next text based on certain tokens you have put in. So that's how it works internally. So if you give like a lot of unwanted words which does not get a good weight, it will just ignore it. And the most important next word prediction comes on what exactly this models understand behind the scene. Prompting, this is instructional prompting. So you can summarize, write, and keyword extraction based on that. A lot of people are now using to create online courses and those things. Dialogue, we saw it. You can query, you can ask them to multiply, subtract, those kind of things. Reasoning is another. Now this is interesting. This you might be already using it, or to an extent. If you prompt, this is a very good example. In certain language, sometimes it gets confused, or sometimes if you have a clear direction, it will do the good job. This is interesting. Now, we talked about how to prompt. Now, how do we take whole internet data and use it for ourselves? That's called tuning. You can subset certain segments going into large language models and focus on that and generate for example, legal or a medical advice, rather than looking at the whole corpus. So we will talk how to do that. That concept is called fine-tuning, bringing our data set and retaining the model by turning every weight into LLM and require a big training job. We'll see how these things are done in detail. These are the places where you can you can use it everywhere, but these are some of the cases where things have been very advanced and very excitement is here around. So healthcare, a reusable component of medical, asking, adopting questions, human AI collaboration, those kind of things. Okay, now next concept what we have here is GAN. These are very important things. Is a machine learning model with two neural networks compete with each other using deep learning. So GAN referred as generator and discriminator. And generator is CNN, convolutional neural network, and discriminator is deconvolutional neural network. So we'll see how they work. So in terms of very simplified way to explain this, can generate a content which is not at all true. For example, it creates a human being which does not exist, takes some number vector, and then say that this is a human being. Discriminator, the other deep learning model, knows how to tell that this is a fake image. So it will say that this is not a human being, this may be a cat or a dog. So based on that, they compete with each other, and generator in next expression will try to go to very close human being face. Then discriminator will say this is not true, and they compete with each other until generator beats the discriminator and a fake human being face is created in a very simplified way. So how does it work? Generator's model creates their own training set while generator is trained to produce a false data. As I was saying, it is going to assume some vector and throw to discriminator and labeling that vector as this is a human face, and it will say it's not, and they compete. The discriminator network is taught to distinguish between generator and manufactured data, and true example is trained on true things. So this loop continues, and once the generator wins, a new image is created. This is a typical example. I can see question, what is unstructured content? That's good. 13, 3 jobs of people focus singularity, prompt engineering, all companies. I'll answer that, Fatim. Thank you for the question. So this is typical synthetic data where I took this vector, which is not even a human face, and ran into deep learning generative AI model. From there, it just discriminator kept depending, and generator kept prompting or fine-tuning it, and a new human being is created, which is not true. This person does not exist. So this kind of things, you can find it on this website. It's called thispersondonotexist.com. These are, again, AI-generated human beings, which is very common on internet. George, how AI app best to develop AI video and facial? I'll answer, George. Hang on. That's the next topic. Sorry, guys, I may run a little bit longer than normal time because there's so much content to cover. But this is how synthetic data is created. And I'm going to show you how did we use it. This is one of our platform. It's called Twilight, which is an AI-driven learning platform. And what we do here is, when you are like right now, I am on the camera, we can figure out your attention span. We can figure out your sentiments, if your emotions. Are you boring? Are you interested? Are you sleepy? Those kind of things. This is just in terms of data gathering on the facial side. If you are a practitioner who wants to go more technical deep or fine-tune the model, there is something called Hugging Faces, this community which has a lot of open sources now available. I did not check the licensing for it, but you can do literally, the growth of this community is so fast. For example, video, as someone was asking me, OpenAI Whisper, Microsoft has little Comic Factory, Leadership Board, a real-time latent consistency model. We'll look at in the medical use case, that one, and the printer models. There are thousands of them. It says browse more than 100,000 applications. So it's kind of, as I was saying, a bigger opportunity than the internet, I think so. This is another concept called semantic data. What is semantic data? Is referred as data that only defines by its value and also its context, goes beyond the traditional data format by embedding and enriching metadata that describes the relationship and the property in data element. This makes data machine readable, understood, and more human-like. This is an official Wikipedia definition, but imagine which we'll talk in the next use case. You are training a facial recognition. We have it in the makeup app, and you need millions of the faces which has makeup, and you are going to predict what products they're going to use. So in this kind of situation, which was real for us, we were able to generate semantic data. One person face can be multiplied in different ways to generate multiple faces and multiple combination of makeup. So for the definition of semantic data, you take a data piece, add some semantic, and smoothen and integrate and make a version of it. In terms of, let's say musicians, right? They play a lot of piano and different instrument. You can mix the music, what the DJs, that's called semantic data. You can look at from that point of view. So linked data, knowledge graphs, and semantic annotation in research papers. So these are some technical concepts behind it. In this case, which I showed you here. So how is it happening is noise. This is a generator and this is a discriminator. You inserted some original data and discriminator creating with it. And towards the end, you saw something which does not exist, but it's very true to the original one. Talk about this. This is the app which I was talking, which we had challenge into, and we still have this we are working on, where we are able to take a person's face and see what kind of makeup they need. And based on that, we are able to refer the person to a particular set of makeup items. To do that, we have to take these faces and generate multiple faces out of these faces with different makeup style. That's a typical example of semantic data. Another very good example for people who are in the medical field, create an infinite model image data with generative AI. This is one of the most desired use case. This is the 20% of the excitement in $15.7 trillion change. I have a very basic presentation here on this. Next one, possibly I'll show you a model. So what Gen AI models can help to identify complex disease mechanism and predict clinical outcomes and prescribe tolerant. This is the goal, treatment for the patients. So what generative AI goals are? There is a platform called Medical Open Network for Artificial Intelligence. It's built in UK, and they have done a lot of this kind of semantic data generation. And I got some screenshots for it. So latent data diffusion, they got this MRI, and they are changing some context here. By changing certain parameter based on this 3D model, they are able to generate tons of CT scans of similar situation with little bit variant. And this is what generative AI is so powerful in terms of creating the data set which you will be able to use in your experiment. I started as an entrepreneur in 2015. The biggest challenge any customer I go to is data. And now that problem is almost minimized. I won't say solved, but minimized to an extent where semantic data can be generated by just few inputs. Here in the same thing, generating a brain image with diffusion model, they have given this age and gender or a couple of other parameters. Take the same image, male, female, just change the volume of what you need, age of the person, and it generates data based on what you need. So age and volume, you can just play around it and you can generate some. I'm not a medical professional, but this kind of images, MRI images can be generated. This is another, adjust the gender or disease. So it goes as simple as that. You can just increase certain parameters, and based on that, you just say that I need 200 images of this, and it will generate. And hopefully the AI models can train on those data and will be able to predict a disease which was very hard to diagnose before. These are a couple of examples on this topic. Now we talk about all the use cases. Now let's look at technical part of it a little bit. Someone asked what app is the best for developing AI video and social media? I don't know the answer myself for that app, but I can show you the process. So generative AI lifecycle, if you have done some machine learning and AI experiments, this is how it looks like. You bring your data, you do some evaluations, and based on that, you build your model and you train your model. and fine-tune your model. So that's standard AI practices. But here is where the integration of large language models comes in, prompt engineering. So we'll see how this is done. And if you haven't done machine learning or AI projects, these are the steps. You bring the data, you write an experiment, you understand the feature, what is needed, you build some model, you train and test the model, and then based on that, you do the prediction. This portion is the new one. Now, let's say you're working on a diabetic healthcare problem. You want to know what others people are eating food, if their blood sugar is high, what they feel, what they do to reduce their blood sugar. All those things can be mined or tapped from the large language models. So we'll see how to do that now. This is a little bit technical. So this is the process how it is done. Transfer learning is a concept where you pass information from one learned model to another learned model. So by weight management, weight transfer, fine-tune the model, safety mitigation, distillation. These are some. So what we'll do is, in terms of concept, tuning the model. Quantization involves reducing the precision of large language and weight activation. Knowledge distillation, rather than focusing on the whole corpus, you will distill down to what you are focused on and reduce the low-ranking factors. And then architecture change, which I already said here. You will integrate your LLM here. And parameter sharing. Yesterday, I saw the real, not the real news, which says BlackRock is putting the biggest money into embedded stores, like the one which will have this kind of features like parameter sharing. So everything you train on ChatGPT, the path to get it, the large language model, weight management, activation, this is called embedding. This is the key to someone's brain. If you know how to prompt a large language model or prompt my brain, and you are able to store, that's where the major money is. So that's what it means by parameter sharing. Now, these are some tools which we need. We need to learn a little bit to how to fine-tune into large language models. That's called LangChain. So LangChain provides a framework of changing multiple large language models, chaining them together and bringing them into a single model and combine with different complementary strength to get some output. Some example is conversational AI, documentation, code generation, you can use it. The second framework which we use is Lemma Index. I will show you the difference between LangChain and Lemma Index. So Lemma Index is advanced framework designed for amplifying the capability of LLM model like ChatGPT-4, inherited power of being vast public to reduce the data set. It has API and also it can take an input from you. So for example, if you're running a medical hospital or research lab or legal firm and you have a bunch of cases and you want to input your case to the large language model and get some output from the corpus large language model and do some kind of work, that Lemma Index helps you to do those kind of things. The technology behind is called RAG, Retrieval Augmented Generation, which takes the document, load it, parse it, index it, vectorize. So vector store and then query and response. So document loading, this is word embedding and you'll come into indexing, and vectorize, now something new concept or existing concept, you can say it, vectorize store or vector database. So that's how it understands, and from there it transfers to the query, which is large language model prompting, get the response and get back. This is how RAG works. So you have pre-trained massive data set, you throw to the large language model, user response, query, and knowledge-based LLM is poke in, and you get something out of it. Same thing, RAG, you can put your document as an agent and then write a query, object intent and retrieval. So let's look at it. How do we combine these two and how do we now build our own applications? Let's say if you're trying to build up a law firm or sales application, how do you now get into ChatGPT-4 or any other large language model if you're building a medical application and you put your data and you fine-tune it, you do a vector indexing, from there you bring the output and push it back to your system. So step number 1 will be LangChain and Lemma Index integration. LangChain will get into ChatGPT or OpenAI, and Lemma Index will take your content and construct a vectorized index. So that's what it's going to do here. And then your open form natural language prompting by the users, so they work together. This is what a big architecture look like if you're designing a system. I know it might be very technical, but you have your insight, context has come, it will break down into chunks, and then embedded API, it will further convert into semantic index, which is a vectorized database, go into it, and then hit the large language model and get the response. At high level, that's how it works. We are here. I sit in Orange office at 3rd floor. You can join us in one of our live events. This is our team. These are the people behind this initiative. Myself and IFCD, who is our chief scientist, has a couple of PhDs and masters. Nanan is also PhD. I'm repeating our services, our ecosystem, how you can get involved with us. This is a B2C model where we kind of do a hands-on training for skill building and experience sharing. Target audience are student, professional, and entrepreneurs most of the time. The second way to get involved with us is our B2B side, where we build models. We help you to do your prototype, or we can build the product across it. We also help you to do some research development if you want to at that stage. And the third is where we partner with any big firm like in Singapore or here also 2 or 3, one medical, one real estate is here, where we become your partner and we try to build product together. And if everything is all right, we also play as an investor. We recently launched this new initiative, which you saw here, to bring a real program for AI for professionals where you'll get real work done. So if you have any concept and ideas, you can bring in. If you are entrepreneur, student, scientist, engineer, these programs cover all of it, from basics of understanding what is large language model, what is machine learning, what's natural language processing, to building your own desired product. For a few hours, you will get mentoring from us. We also offer on the B2C side, these are a couple of other programs, which is for PhDs and masters only. For professional, the next one is data science for professional, which is for the job seekers or someone who's doing an machine learning with large language models or data science with large language models.